Hi, in this video we are going to study how to design some surfaces starting from curves. In particular, we will begin with helicoidal surfaces. The main goal is to model ruled surfaces, the lines of which rest on a helix. On the screen you can see some examples of surfaces obtained from helices. A ruled surface can be described as a set of points swept by a moving straight line. In this video we are going to consider two kinds of these ruled surfaces. Cylindrical surfaces, where all the lines of the surface share the same direction. Helicoids, that are ruled surfaces obtained from lines that go from a helix to the axis of the helix. But there are others. In particular, in the following video, we will have two more examples. The cylindrical surfaces are obtained by moving along a curve, alpha, a line with vector u, and hence a point of the cylindrical surface can be parametrized as alpha plus a parameter s times the vector u. Note that the parameter s is the one which moves the point along the line. In this way, we can model the railing of the DNA tower as the cylindrical surface obtained by moving the segment with direction the vector u along the circular helix on the screen. Or the Great Mosque of Samarra, which can be also parametrized as the cylindrical surface obtained by moving the segment with direction the vector u along a helix constrained in a cone as it is shown on the screen. Another way to parametrize ruled surfaces is by considering the set of lines that lean on two curves, for example alpha and beta. The direction of these lines, the vector u, is the difference between beta and alpha, and note that it depends on t. Then we can parametrize the surface as the points alpha plus a parameter s times this vector u. Again, the parameter s is the parameter that moves the points along the lines of the surface. For example, on the screen you can see a sketch of the surface obtained by joining points of the curve alpha, which is like a sinus, with a straight line beta. And the parametrization of the surface. Note that if s equals 0, we have a point in the curve alpha, and if s equals 1, we have a point in the line beta. We now construct another example of this kind of parametrization, the helicoidal surface. We begin with a circular helix, cosinus t, sinus t, and t, and a parametrization of its axis, 0, 0, t. That's the straight line beta. The vectors joining points of the helix and the axis are the vectors u, b of t minus alpha of t. A parametrization of the helicoidal surface is thus obtained by considering the parametrization of the curve alpha plus the parameter s times the vector u of t. Note that the parameter s goes from 0 to 1. That is, the points in the surface goes from the helix to the axis. We can also model a different spiral staircase by considering the parameter s from 1/2 to 2. And with the previous parametrization we can model the DNA tower in Perth, Australia, a double spiral case staircase. Actually, not only the DNA tower, now we have the necessary elements to model any spiral staircase we want to design.